All right, 38 said the directions were write each decimal as a fraction or a mixed number. All right, so we end up with 7.6 is number 38. All right, the only thing I need to worry about changing into a fraction is the 0.6. So do not write this as 76 over 10. Everyone's eyes are on the board. Don't write this as 76 over 10. I'm not saying that's wrong. I'm saying it's going to get confusing. Okay? You have a whole number part already there. So leave it as the whole number part. Well, what is 0.6 as a fraction? Brendan? 6 over 10. So I'm going to see that. You cannot, when you are with me, you're not leaving work off. All right, you're writing down exactly what this is, and then you're going to simplify that. Well, 6 and 10 both have a common factor of 2. So 6 becomes a 3, the 10 becomes a 5. So this is 7 and 3/5. This is what I should see. All right, I don't recommend doing this. 76 over 10. Well, you could get it, you probably can get it right. All right, what you're going to end up doing is you're just going to end up dividing this, and you're going to say, okay, well, this is 7. I have 6 left over, and you get the same thing. Do you know what I mean? Like, it's extra work you don't need to do. So don't do that. And for what we're doing today, you don't want to do that. I want you focusing on when you're changing a decimal into a fraction, the only thing you need to change is the decimal part into a fraction. Okay, are there any from the homework that you guys do want to talk about? Alex? 44. Okay, so let's take a look at 44. All right, so 44 gave us, it says, you and a friend are collecting leaves, and your collection of 45 leaves. So we have 45 leaves. We have 4 oak. All right, this is yours. All right, we have your friends. They collect 36 leaves. And in theirs, they have 3 oak. All right, so here is the data. Whose collection has a greater fraction? Of oak leaves. Okay, so I'm going to write you, and I'm going to write your friend. So Alex, what fraction of leaves are oak leaves for you? Excellent, so I have 4 over 45. What fraction for your friend? 3 over 36. Okay. So for us to compare these fractions, one of the two situations has to be. They either have to be fractions with the same denominator, which we can do, or we can change them into a decimal and compare their decimal form, okay? Because of what we are doing in our lesson, we're changing fractions into decimals. That's what I want to focus on, okay? So first of all, I am going to divide out common factors and simplify this 336. That ends up being a 1/12. That division is going to be a lot easier. All right, so now I'm just going to do this division. So I have 4 divided by 45. All right, so 40 divided by 45 is 0. All right, 4 divides into 40 10 times. Obviously, that's going to be too big. I'm going to try 8, just to be safe. So I'm going to try 8. So 8 times 5 is 40, carry the 4. 32 plus 4 is 36. That ends up being a 40. All right, if I bring a 0 down, I'm in exactly the same place. So this is going to be, if I did this right, this is 0.08, and then the 8 starts repeating. All right, so this is equal to 0.08 repeating. Are you cool with that? Okay, I'm just going to finish, but I'm glad you found it. Okay, so then I have 1 divided by 12. I'm going to do that division over here. So 12 divides into 10 0 times. 12 divides, I'm going to try 8, only because this is an 8. I'm going to try this as an 8, just to see what happens. All right, if they say this is an 8, so that's 16, carry the 1, it's 96. All right, so that's a 9. That's a 4. I'm going to put a 0 here. I'm going to bring that down for 40, right? I did that right? Okay. 12 divides into 40 3 times. That's 36. That brings my 4 down. So this ends up being, so I'm going to bring this 0 down. I'm going to stop. All right, even if this was not repeating, I can just stop right here because I know that this is going to be approximately, hang on a second, I wrote this one wrong. That's a 0.8 repeating. This one is 0.083. Even if it keeps going, it doesn't matter because we are comparing these two decimals. And we can tell right away that this one is the bigger one because it's going to be 0.088888. This one's already 0.083. So we know this is bigger. You guys cool? All right, put this away, get your notes out. So today is the 9th. We are still in 5.1, so 5.1 continued. We're talking about rational numbers. Okay. So yesterday, we talked about changing fractions to decimals. Yesterday we talked about changing fractions to decimals. So something like, I'm going to do a super easy one, something like 1/2. All right, we would just do the division. I have 1 divided by 2. I know you guys already know what this is, but I'm just using an easy one. This is 10, 2 divides into 10 5 times. So this is 0.5. So we talked about changing fractions into decimals. We also talked about changing decimals into fractions. What decimals did we focus on yesterday? For decimals into fractions. What type of decimals did we focus on? Cullen? Yeah, we focused on terminating decimals. So something like negative 1.62. Somebody write that as a fraction for me. Ada? Yep, negative 1 and 62 over 100. That negative 1 I'm going to leave. 62 is divisible by 2. That gives me 31. 50, 10, 100 divisible by 2 gives me 50. So this is 31 and this is 50. So it's negative 1 and 31/50ths. All right. What we did not do is I did not talk to you about repeating decimals into fractions. Do you guys remember yesterday when we were talking about rational numbers? And I asked you guys 0.3 repeating, what that looks like as a fraction. And somebody said 3/10. How many of you guys remember saying that? Someone saying that? All right. Why is 0.3 repeating, not 3/10? Patrick? Yeah, it keeps... Yeah, it's... exactly, right? It's approximately 3/10, but it's not exactly 3/10. So technically, we need to figure out, if I gave you a repeating decimal, you need to figure out, how do I change that into a fraction? Why is that 1/3 and not 3/10? Okay, so let's take a look at the process. I'm going to use 0.3 as my guide. We're going to do a couple of these. All right, so I'm proving to you that it's 1/3. Are you guys cool with that? So right now in today's class, we're going to focus on changing repeating decimals into fractions. All right, so for those of you that are adverse to showing all your steps along the way, other than the fact that you have to for me, all right, don't skip things. You have to you have to understand each step to really know what you're doing here, so really pay attention and take really good notes. So I'm going to do my example off to the left, and I'm going to write my steps off to the right. This gets complicated the first time you do it, but the more you do, the better you're going to get. 0.3 repeating. Okay, the first thing you're going to do is I want you to set the repeating decimal equal to x. All right, so x equals 0.3 repeating. Are you guys good so far? Okay. This second step, you don't necessarily have to do this, but I feel like the first time you do this, you do this process, you're going to need to. So this step is kind of optional, but for now I want you to do this to understand how this works. The second step is I want you to set x equal to 2 of the repeating parts. I know that seems weird, so I'm going to do this in a different color so you know what I'm talking about. So I'm going to say x is equal to, so I'm just going to add a repeating part on there. So instead of 0.3, isn't that the same thing as 0.3? 3 repeating? Can I show 2 of them? How many of you guys are okay with that? So 0.3 repeating is the same thing as 0.33 repeating. So I'm showing 2 of our repeating parts. Are you guys good with that so far? Okay. My third step is I want to determine from the given what place value the repeating part goes out to. All right, so from our given, so I'm going to go back to our given, I want to determine what place value our repeating part goes out to. So if I take a look at my given, what place value is that 0.3 repeating in? Addison? Yeah, so this is in the tenths. So when I write this down here, I'm just going to show you what I mean by this. If I have 0.3 repeating, this 0.3 repeating is in the tenths. All right, so multiply x equals 0.33 repeating by 10. All right, so I'm going to do this in a different color so you can see this. So I'm going to put a little pink thing here so you can see this is what I'm doing. So I'm going to multiply the x by 10 and the 0.33 repeating by 10. So by setting x equal to our repeating part, I have now created an equation. X equals 0.33 repeating. And so what I'm doing in this step, my goal in this step is to get one repeating part in front of the decimal. All right, so my goal is to get one repeating part in front of decimal. That is my goal. So by multiplying both sides by that 10, because this 0.3 repeating was in the tenths, I get one entire repeating part in front of the decimal. So when I do that, I have 10x is equal to 3.3 repeating. For all of these, you're either going to multiply by 10, 100, 1,000. It just depends on what place value your repeating part goes out to. Are you guys good so far? All right, so I'm going to flip because I need more room. So I'm just going to rewrite that 10x equals 3.3 repeating, and I'm going to go to step number 4. Who needs to see what's up there? Cullen, what's up? Okay. Who needs to see what's up there? Okay. So now I have my step number 4. All right. The problem with our decimal is it has a repeating part. So in step 4, I want you to subtract 0.3 from 3.3 repeating and 1x from 10x. Because if you remember, x equals 0.3 repeating. I want to get rid of the 0.3 repeating. All right, and since x is equal to 0.3 repeating, I'm subtracting the same thing from both sides. So I'm going to subtract 0.3 repeating from the right side. I'm going to subtract a 1x from the left. That will always be subtracting 1x. Always. Because I want to get rid of the repeating part. That's the problem with this decimal, is there is a repeating part. And now this allows me to get rid of that repeating part. All right, so the 0.3 repeatings cancel each other out. What's 10x minus 1x? Amanda? So I have 9x is equal to 3. So I have effectively, in everything I did in steps 1 through 4, I have gotten rid of the repeating part. Now, with step 5, solve for x. So I'm just going to divide everything by 9. X equals 1/3. How many of you guys are okay so far? I know you're kind of like, I'm not sure really what we just did. So we're going to do another one, okay? Addie. Okay. Questions on any of that so far? All right, so let's do another one. So I want you to change 1.93 repeating to a fraction. What part am I actually changing into a fraction? What part am I actually changing into a fraction? Cameron? The part after the decimal. So all I need to worry about right now is that 0.93 repeating. I'm going to put that 1 off to the side, and I'm just going to save it for my answer. So when I'm done, I'm just going to put a 1 in front of it. Okay. So my first step is set x equal to the repeating decimal. I like to do that again with the second repeating part, just so when I multiply that repeating part by either 10, 100, or 1,000, I can see why I get one full 1 in front of my decimal. Okay, what place value does our original decimal go out to? Matthew? The hundredths. So what does that mean? I'm multiplying both x and the repeating decimal by. Ada? 100. So I'm just going to multiply both sides individually by 100. When I multiply by 100, what happens to my decimal point? Valentina? Excellent. I move my decimal 2 places to the right, which gives us a repeating part in front of the decimal, which is what I wanted. So let's restate this. This step, this gets a repeating part in front of the decimal. And that's what we wanted. What's our next step from here? What's our next step from here? Ada? Subtract what? Yeah, so we want to subtract off the repeating part. So I'm going to show I want to subtract 0.93 repeating. Well, whatever I do to one side, I have to do to the other. So what am I subtracting off the other side? Amanda? Yep, I'm subtracting a 1x off. So Sarah, when I subtract 100x minus 1x, what do I get? 99x equals, when I subtract 93.93 repeating minus 0.93 repeating, Brendan, what do I get? Yep, I just get 93 because those cancel each other out. And now I just need to finish. I divide both sides by 99. I need to simplify this fraction. 93 and 99 are divisible by 3. So that 93 is going to be 31, and that 99 is going to be 33, right? Is that my final answer? Addison, what's my final answer? Excellent. So what is it? Yes. How many of you guys are cool with that? You guys good? All right, so make sure you understand those steps. All right, so now what I want to do, now that we have that down, all right, I want to talk about ordering numbers, putting them in order of least to greatest. Are you cool so far? All right, so you have 2 examples of changing repeating decimals into fractions. Please follow the steps for this. All right, let's talk about writing or ordering numbers from least to greatest. So I want to order rational numbers. So what that means is we want to put in order of least to greatest. Now, if you want to draw a number line, you can. You do not have to. Let me ask you something. Numbers, to be able to order numbers from least to greatest, what has to be the case for those numbers? So think about the ones that we did with which fraction is greater. All right, what has to be the case with all of our numbers for us to order them? Molly? They all have to be in the same form. So they either have to all be fractions with the same denominator, or they all have to be in decimal form. All right, so we need to make sure we put all the numbers in the same form. So all numbers must be in the same form. It does not matter what form. So if you find it that it's easy based on the numbers that you can do a common denominator, then put them all in fraction form. If you're like, oh, this is going to be too hard to find a common denominator, then just change them all into decimal form. It doesn't matter. Okay? So I want you to put these numbers in order of least to greatest. So order the following numbers. All right, so I have a negative 5/4, a negative 0.2, 4.31, negative 3, 5 halves, and negative 13 thirds. Now, because of time, I will let you use a calculator. All right, for this right now. I do want you to be able to do this division and master the division. All right, but we don't have a ton of time. In your homework, I would like for you to do this division. If you're changing them all into decimals, I'd like you guys to do this without a calculator. This is the honor system, all right? Because on the high school placement test next year, you will not get a calculator. All right, do this work, please. Yeah. Yeah. Oh, for sure you can check it. Yep. Whatever you can do mentally, do mentally. So -5/4, you should be able to put that as a decimal without thinking about it. Because we have a 4 as a denominator, a 2 and a 3, and we have decimals, this 3 throws me off, so I feel like we need to change everything to decimals. If this was maybe another 2 or like a 5, we might be able to change these into fractions with like 100 as our denominator, because those would be easy to get a common denominator. All right, but this 3 as a denominator throws me, so I would be doing everything in decimals. So again, the ones that you can change into decimal mentally, change them into the mentally. How many of you guys know what -5/4 is as a decimal? Without even having to put it in a calculator. What would it be, Danny? Excuse me? Yeah, that's -1.25. I'm just going to circle it because I know that's what I'm comparing. How about 5/2? What do you know that's going to be as a decimal? Amanda? Yep, that's 2.5. 3/13 is the one you're probably going to have to put into a calculator or do. You might be able to do it in your head. What type of decimal do you know that -3/13 is going to be? Danny? Repeating, why? It's over 3, absolutely. You might be able to do that in your head. How many times is 3 divided into 13? Valentina? 4 times, so this is going to be -4. We've got 1 left over, right? Which gives us a 1/3. So this is going to be -4.3 repeating. If you threw it in a calculator, that's fine. What's my smallest number? What's my smallest number? Colin? So, yep, -4.3 repeating. I'm going to cross it off because I have it. What's my next one up from there, Colin? -3. I'm going to cross that off. What's up from there? Excellent. Keep going. Excellent. Excellent. How many guys find it helpful to cross them off once you've done it? Excellent. Just be organized. You guys cool with this? Okay. Please make sure you have your notes in front of you when you're doing the work, repeating decimals into fractions, so you're really paying attention to those steps.